What's going on, Algebra 1? I'm sitting at the house, sitting on the couch, helping you do your homework. So I hope we're getting more and more people each day to watch the video, especially tonight since we got some word problems about some of the stuff we've been talking about. We're talking about equations, we've been talking about inequality, so now it's time to really see some word problems that really use some of the ideas that we've been talking about. So here we go. Carla has $90. That is a starting amount. It says she makes $6 per day. She's walking a neighbor's dog for half an hour. That half an hour could be important, just depends on the rest of the problem. She's making $6 a day, but she's spending $7.50 each of those days eating lunch. So which inequality could be used to show the number of days it will take for Carla to have less than $30? So that last part really suggests that she's losing money every day, because if she started at 90, eventually she's going to have less than 30. So let's kind of think about why she's losing money. It doesn't say she's walking multiple dogs. It's not like she has a route where she's walking, 4 or 5 dogs each day for half an hour. It sounds like she's just walking one dog for half an hour, getting $6 for it. Okay? And so if she's spending $7.50, it's like she's running out and spending that $6, and then she's also spending like another $1.50, it looks like, from her starting amount of 90. So eventually she's going to be out of money unless she makes more money walking dogs, or if she cuts back on this lunch she's getting. So let's kind of think about it. She started with 90, and that's why we see all of our answers over here starting with 90. But we got to pay close attention to this word, makes and spends. So if she's making $6, that means eventually we're adding to that amount, but not just 6, really 6 each day. Every day that goes by, she's increasing her amount of money by $6 walking the dog. But however, she's going out and spending money. That's a subtraction. She's spending $7.50, but not just $7.50, it's $7.50 every day. So then that's what X represents. X is representing how many days she does this pattern. Well, again, we're trying to see right here, when will she have less than $30? And so that's why we don't see a line here. It doesn't say, like, when will she have $30 or less? When will she just straight up have less than $30? So we could solve this if we wanted to, but the problem is not asking for us to do that. So it looks like for this one, we need to go ahead and pick C, because that's the right inequality that represents this story. So as we look at the next one, it's talking about population of 2 different towns. Eastville has a population of 32,000, starting value, and is gaining 500 people per year. Lakeside has a population of 45,000 and is losing 1,000 people per year. And again, it wants to know, when will Eastville have the same number? Another word for same number is equal. When will they have an equal population? Okay? So when we're thinking about this, we got to think about which one should have a variable on it. And let's go ahead and throw it out there that we're talking about starting at 32,000, adding 500 each year, versus 45,000 and losing 1,000 each year. So let's go ahead and start thinking about combining like terms. This minus 1,000 is tempting to move first. So I think I'm going to go ahead and consider moving that over. And let's see what that would give us for a new value for our increasing values per year. So more like 1,500 when we move it over to the left side. Well, now I'm wanting to move 32,000. So let's go ahead and move that over to the right side. This is called solving variables on both sides. And that results in a new value. That results in 1,500x equals 13,000. So now let's go ahead and divide that 1,500 over. And if we divide 15 over to get x by itself, basically we're seeing that it takes 8.6 repeated years. So one thing that's important in math is knowing what fractions are equivalent to certain decimals. For example, 0.5 is 1/2. 1/3 is 0.3 repeated. So 0.6 repeated is the same as 2/3. And if you do 2/3, 2 divided by 3, to get that 0.6 repeated, there's 12 months in a year. So having that decimal and multiplying it by 12, we're going to get the 8 that represents the months. 2/3 of a year is really 8 months. So if you really want to be able to answer the question really accurately, saying 8 years and 2/3 of a year is true, but 8 years and 8 months is really exact. So after 8 years and 8 months, these two towns will have the exact same population. So this is one that I want you to try on your own because it's very similar to several of the problems we've been doing in class as well as today we did in class, even on this same paper. So look around on the front and I'm sure you'll see a good example of one that looks like this. Solve for x, get x by itself. Miss Shepherd is getting her windows washed and she finds two different companies. I'm currently trying to get new windows in my house. Windows are pretty expensive, so I plan on shopping around. I'm thinking about several different things. I'm thinking about the price per window plus the installation. So definitely an important skill to have so you don't spend more money than you need to. But she's not buying new windows. She's just trying to clean them. The first company, Clean and Fast, they're charging $50 for a fee plus $2 per window. And this other company, See Out the window kind of deal, it charges a $20 fee, but it's $5 per window. And so they say if X represents the number of windows you're washing per house, what does the equation 50 plus 2x equals 20 plus 5x, what does that represent? And so the profit margin for each company, the profit is how much money they're making off of you. Okay? We really don't know that. We don't know what the cost is for them to run their business. We don't know any of that stuff. So there's no way we can talk about profit margin. The windows per week each company washes, there's no way to tell that. There's nothing about the problem that's talking about it because it's only talking about what it would cost if you charged, or if you went with the first company versus the second company and all what they charge. A cost comparison between the two companies. Okay, so that is given, like in the yellow and in the green, they are doing that, but specifically the question says if X represents the windows washed, how many? What does this equation represent? So we've been talking about in all these different problems, like when are they equal? And that has to do more with when will the cost be the same? So for example, for one of these companies, we should just go ahead and say, if I'm only wanting to wash one window, I should probably go with the one in green because if it's $20 fee and you're only doing one window, that would cost you $25. Versus the other one would be $52, okay? But if you think, well, I really need to wash like 100 windows. Well, 100 windows would be 5 times 100, 500 plus the 20, so that's going to cost us $520 to do 100 windows with the one in green. But $2 per window, 2 times 100 would be 200 plus 50, that's only $250. So what happens in a lot of cases is that one is better than the other, but it depends on how many hours or how many windows or how many of whatever you're wanting to purchase. And so it's real important to kind of think through the pricing because you don't want to spend more money than you need to. So that one's more about when the company's cost is equal. Here's another problem with no context. It's just solve this equation, find the solution. So another one that I think that we can try at this point in the class. Go ahead and try this one on your own. We'll move forward. I love chess. Great game for the mind. Everyone should learn how to play. It really does help you in life, understanding how to play chess. So let's look at a chess problem. It says a chess club has 500 members, but is losing 30 members each year. A computer club, they have 130 members and they're gaining 20 members each year. So this is very similar to the population situation. One of them's increasing, one of them's decreasing. And really it says after how many years will the clubs have the same number? Another word for same, equal. Okay? So if we can set up what the expression would be for the chess club, what the expression would be for the computer club, we can kind of solve and figure out like what X value, what number of years would make them the exact same. So, starting with 500, losing 30. It's going down. They're not going up in membership, so we don't want to add 30X. We want to subtract. Well, the computer club has 130 members. They have less, but they're gaining. They're going up. So like one's going up, one's going down. Eventually they're going to meet. And they're going to have the exact same number of members temporarily until the next year, and then one passes the other. So I want you to solve this one now that I've talked you through how to set it up, and we'll talk about it tomorrow. And that's pretty much it. So please, thank you for watching the video. Any part that I didn't do, for example, this one here and this one here, you are responsible for trying that independently. Even though I didn't do it in the video, I am really expecting you to attempt that problem on your own. And if you cannot do that problem at all on your own, you need to come see me outside of class so we can kind of catch you up with some of these skills. Hope this video was helpful. Have a great night. Please plan on coming to the Fulton game tomorrow. It's a big Battle of Broadway. See ya.